Today's lesson is on solving special types of linear systems. Today we'll be talking about the number of solutions of a linear system. Up until this lesson, the systems that we've been looking at have had exactly one solution, meaning that the two lines crossed at one point. Today we're going to be looking at inconsistent systems. That is a system with no solution, meaning the lines never cross or are parallel, and consistent dependent systems, linear systems with infinitely many solutions because the two lines are the exact same. In example 1, we're going to find a linear system that has no solution, and we're choosing to solve this system through graphing. We will also choose to solve it through elimination. When we solve it through graphing, we graph each linear system. Now, to make this easier to solve, we need to solve each equation for y. And in equation 1, we're going to move the negative 2x to the right side, making it positive. So it's going to be y equals 2x plus 1. And in equation 2, same thing. We're going to move the 2x to the other side, and that'll give us y equals 2x minus 3. When we graph the linear systems, either in our calculator or using slope-intercept form, we notice that they do not cross. They both have the exact same slope, making them parallel. Parallel lines do not intersect, so the system has no solution. We can also do this method through elimination. The equations that we had are already lined up, so actually this one would almost be easy enough to do not through graphing. We do have to change signs, however. To subtract the equations, you would need to change the signs of one of the two, okay? Making that a positive, that a negative, and that a negative. The x's and the y's would cancel out, leaving us with nothing on the left side. Negative 1 minus 3 would give us a negative 4. The variables are completely eliminated. This is a false statement. 0 does not equal 4. No matter what x and y is, you will have no solution. And that would be how we would answer this, as no solution. Our next example is of a linear system that's going to have infinitely many solutions. So I have my two equations here, and I'm going to have to solve them both for y to be able to graph them. So for the equation 1, I would have 3y equals negative x minus 3, and then I would divide both sides by 3. That will leave me with y equals a negative 1/3 x minus 1. And for equation 2, I would have 9y equals negative 3x minus 9. Divide both sides by 9. That will leave me with y equals negative 1/3 x minus 1. If you notice, those are the exact same equations. So when I go to graph them both, they're going to be the exact same line. They cross at negative 1. And they have a slope of negative 1/3, meaning I'm going to go down 1, right 3, or up 1, left 3, leaving me with this. But as I said, they reduce to the exact same equation, meaning that they're the same line. So any point on the line is a solution. So the way we want to answer this is we want to say that the linear system has infinitely many solutions. To use the substitution method also is fairly simple. We would want to solve equation 1 for x. This is in the substitution method. Personally, I believe it's easier to do elimination method, especially in this one where everything's lined up. You just have to multiply first, but we're going to do it through the substitution method. Equation 1, the original equation was x plus 3y equals negative 3. To solve that for x, you're going to simply subtract the 3y on the left side, and you'll get negative 3y minus 3. Then you would take that and substitute it in for x in the second equation. So we're going to substitute negative 3y minus 3 for x. So that's going to give us 3 times negative 3y minus 3 plus 9y equals negative 9. We will distribute. 3 times negative 3 is negative 9y minus 9. The 9y's cancel out, leaving us with negative 9 equals negative 9. That is a true statement. We've eliminated the variables, and we were left with a statement that is true regardless of the values of x and y. And then that tells us that the solution has infinitely many solutions. And we have a checkpoint. It says tell whether the linear system has no solution or infinitely many solutions. I'm going to choose to do the elimination method on both of these, even though they're not lined up. To get number 1 lined up, I'm going to move that 2x over here, which is going to make it a negative 2x plus y equals negative 7. And my other equation is 4x minus 2y equals 14. I'm going to multiply this first equation by 2. And that will give us the tools that we need to eliminate the variables. That will leave me with negative 4x plus 2y equals negative 14. And the bottom one will still be 4x minus 2y equals 14. Those cancel out, those cancel out, and those cancel out, which leaves us with 0 equals 0. That's true. When it's true, we say it has infinitely many solutions. For number 2, I'm going to do the same thing. I'm going to move the 8x over to the left side, which is going to leave me with a negative 8x plus 2y equals 4. I have a negative 4x plus y equals 4. I'm going to multiply the second equation by 2. So that's going to leave me with, for the first equation, still negative 8x plus 2y equals 4. That will become a negative for the second equation. It's going to give me a negative 8x plus 2y equals 8. I need to change all of the signs in one of the equations. So we're going to make that positive, that one negative, and that one negative. Those cancel out. Those cancel out, so I have 0 equals 4 minus 8 is negative 4. That's false. When it's false, our answer is no solution. And one final bit of information for this section. In the 3 types of solutions that we've talked about, there are 3 different ways that we can answer. Most of the time, they're going to have one solution. So nothing's going to change. We'll do things the way that we have in all of the previous sections. The lines intersect. The lines have different slopes. So as long as the slopes are different, they will cross somewhere. It is no solution if they are parallel, meaning they have the same slope, but they'll have different y-intercepts. And finally, infinitely many solutions if the lines coincide. They have the same slope and the same y-intercept. But keep in mind that most of them will still have one solution. And that concludes section 7.5.